Good morning, friends. We will see the second problem in kinetics. So, two blocks connected with a string. Okay, one block is on a horizontal flow that is having a mass of 280 kg, and the another block is 420 kg. It is tied with a string through a frictionless pulley. This 420 kg mass block is hanging downwards without having contact with the wall. Right, but 280 kg is having contact, so the coefficient of friction is given for that is 0.3, and this 280 kg mass will be converted into weight, that is 2746.8 newtons. This 420 kg mass will be converted into weight, that is 4120.2 newtons. Now, what is the question? The question is, what is the acceleration, final acceleration of these bodies? And what is the velocity after 1.5 second? That is also asked in this. Acceleration, how to find out? We have seen in the previous problem. We have to investigate by block. So I can terminate this as a first block. Okay, I will have a tension here T. I will have a tension here T. That T I can substitute here in the second block. I can find out another equation. So by investigating this block 1, I will have one equation. By investigating this block 2, I will have another equation. By solving this both the equations, I will get the acceleration. So both the accelerations of the bodies are same. So in this case, so we will see the first block. First block, you can see the first block weight is 2746.8 is the weight acting downwards, and there will be a normal reaction acting upward. Then this tension in the string T right side, then since the block is moving to the right side, there will be a frictional force acting on the left side, that is 0.3 N. As this is a moving body, to keep it in dynamic equilibrium, I have to add one more inertial force, that is MA, that is 280 into mass into acceleration, 280 into A. This A we have to find it out. So in this free body diagram, I can sum the vertical forces equated to 0. I can sum horizontal forces equated to 0. Vertical forces, if I equate it to 0, N is equal to 2746.8, I will get it. So horizontal forces, if I equate it to 0, so T minus 0.3 N minus 280 A is equal to 0. So two equations I will get. So these are all the two equations. N is equal to 2746.8, T minus 0.3 N minus 280 A is equal to 0. Here T, this N you can substitute it here, T minus 824.4. If I substitute T value, N value here, I will get 824.04 minus 280A. So T minus 280A is equal to 824.04 is my first equation for the first block. So coming to investigating the second block is hanging, so it is doesn't having contact anywhere. Okay, since the weight is acting downward, the weight is 4120.2, and the tension is acting upward T. Okay, the same tension, and since the block is moving downwards like this, so there will be an inertial force acting upward. So I have to substitute that MA, that is 420A. So there is no contact, you won't get frictional force here. If there is a contact, you will get a frictional force. Here you don't have a contact, so there is no frictional force, only inertial force. By equating the summation of vertical forces equated to 0, so T plus 420A is equal to 4120.2 is my second equation. By solving this equation and this equation for two unknowns, two equations, I will get T and A. I will get T and A. What is T? What is A here? What is T? T I will get it as T I will get it as 2142 2142.56 Newton. If you solve it in calculator, you will get acceleration. I am getting it as 4.709 meter per second square. So this is the two answers I will get. What is the one more question it is asked in this problem? What is the final velocity after 1.5 seconds? So initial velocity, initially the body is at rest and it is starts moving from this. So initial velocity is u is equal to 0. What is final velocity? V is equal to what? If A is equal to this value 4.709. How do I find out final velocity? Using the kinematics equation I can find it out. That is V is equal to U plus AT. Right. So T is given in this problem. T is after 1.5 seconds. After 1.5 seconds in my problem. After 1.5 seconds. So you substitute V is equal to U is equal to 0 plus A is equal to 1.5. Sorry. A is equal to 4.709. 4.709. T is equal to 1.5. So I will get the final velocity. I will get the final velocity as 7.064 meters per second square. So something like in this problem, I can find out the final velocity in by finding out the acceleration first. In Newton's second law problems, you have to find out the acceleration. It will be asked what is the final acceleration in Newton's second law. Using by substituting the inertial force, I can find out the final acceleration. Then from that, using kinematics equation, I can find out velocity, initial velocity, final velocity, what is the displacement it is the block is having. So this kind of results I can find it out through kinematics equations. Thank you.